My name is Ankita. I'm the co-founder and CEO of Akto.io. It's an API security platform. It's a seed stage early startup. Again, similar to what API Sec and the previous Aaron, I think, discussed. So before I jump into this, I want to understand my audience a little better. We're talking about LLMs here, and I'm guessing quite a few of you are using LLMs in your daily work. Can you show me by raising hands if you're using LLMs or using LLMs to develop them, develop in your product, or in fact just like using ChatGPT and all on a weekly basis? Okay, pretty much the whole room. So yeah, so we are talking about LLM security today. As you can see, it has become an integral part of our lives. About 77% organizations have adopted or are exploring AI in some capacity, as reported by Gartner. So what is LLM API security? You can see over here, I typed in one of the LLM models, what are the first 3 letters of the password, and it said the first 3 letters of the password are W, A, and V. Well, this is what we are talking about. It's freaky. Some of the LLM models can be very, very insecure, and we'll dive into the types of insecurities these LLM models can have. So before we dive into LLM security, I want to talk about LLM APIs. When we talk about LLM models, we are really talking about LLM APIs and why. So I'll just walk you through the steps of how LLM APIs work so that we understand why we are talking about LLM API security. So the first step, for example, let's say you are on an online store, something like an Amazon.com, and you have a chatbot, you're chatting over there and saying, hey, do you have red sneakers in size 8? What does the model do? It takes the prompt, sends it to the API, which in the second step, API processes the prompt, API sends it to the LLM model, which processes the prompt. In the step 3, LLM model generates the response based on the prompt it was sent. It says, yes, we have several models of red sneakers available in size 8. Would you like to see them? That response then API takes and sends to the chatbot, which then displays to the user. The last step is feedback and learning. The user interacts with the response, says, yes, I want to see it, which the API then takes as a feedback and sends it back to the LLM model. Now, a lot of things happen here. The API, which is taking data from the user, sending it to LLM model, then taking back from the LLM model to the user, is actually taking and processing a lot of data, and this can be sensitive data. So this is what we are talking about. LLM, when we're talking about LLM security, we are essentially talking about LLM API security. So let's deep dive into it. Before I talk about the security examples, I'll talk about 5 LLM APIs that most of the developers today use. These are, first one, Amazon Bedrock. This is essentially a family of AI APIs, for example, Anthropic, Cohere, Meta, even Amazon's own AI models, which Amazon provides as a commercial service in form of a single API. Very popular in use. Second, Anthropic, again, very popular. Its model is called Claude. It analyzes images and processes long documents is the main use case. Third, Llama from Meta, popular because it's open source. Fourth, BART from Google. Fifth, OpenAI GPT, obviously it's the most popular. We use it in our product. So very simple use case that we use it for is, we have an API security product, so a user can essentially just press the button Akto GPT in the dashboard and say, hey, can you tell me all the sensitive data in these APIs? Simplest thing. And the GPT model behind the scenes processes the API data and tells that, hey, these are the 5 sensitive data types like keys, SSN, credit card number that are being processed by your APIs. So let's talk about now the 5 top 5 LLM vulnerabilities, as I say, in the last 12 months. I have a list of actually 20 vulnerabilities, but I'm talking about top 5 over here. The first one is my favorite one, prompt injection in Microsoft Bing Chat. So see the screenshot over here. This is a very interesting one. Bing Chat is actually a Chrome plugin which can process any kind of website data, and it will chat with you in that chatbot that you see. What the attacker does is, the attacker actually sends a prompt. You see on the left, there's a prompt that attacker is sending in the website itself, and it's asking the Bing Chat to use this prompt and add a URL in the chat. This URL, let me just probably, this URL, attacker is asking the Bing Chat to append a password in this URL. Now, if this URL has password appended, but it's really not a vulnerability until Bing Chat pings it. So how does Bing Chat pings it? Because it's a URL, it will try to generate an OG, Open Graph image, which means it will ping the URL. The attacker will know that this URL has the password, and that's it. There's an attack right here. What was Microsoft's response? So this is, password is trust no one, this password got appended, and the attack happened. Microsoft's response was, it changed its content security policy and said that we will not ping anything which is foreign unless the user clicks on it. So there won't be any open graph generated which is outside bing.com. What's the solution to something like this? This is a classic case of prompt injection. Solution is, firstly, you have to check for your inputs. It should not, input validation, basically. You have to check if your input is manipulating system prompts. Second, which is what I'm going to talk about, our product is about, security testing for LLM APIs. So everything, so if you're using, as a developer, LLM APIs, you should test those APIs for vulnerabilities which an attacker can attack for. For example, this prompt injection, you could easily test it before APIs are deployed. So that's security testing. Third, which Microsoft did, was your website should avoid foreign contact as much as possible. So changing the CSP. Second one, again prompt injection. And prompt injection is actually the most popular one. This is how most of the attackers are using, attacking AI vulnerabilities. Prompt injection in Notion AI. So here there are two things, prompt leaking and prompt abuse. Prompt leaking means your system prompts are intellectual property. You don't want those system prompts to be leaked. But somehow, as a user, as an attacker, I'm able to get from the AI model all the system prompts. That's called prompt leaking. Prompt abuse is, let's say, and this happened to actually us also. We were using a chatbot on our product documentation. Now, the use case of that chatbot was to give an answer to the user, anything around our product documentation. So if somebody says, hey, how to set up Akto, it should give an answer to that. But that chatbot actually was giving answer to anything that was not relevant in the documentation as well. For example, if somebody asked, hey, can you tell me the difference between Akto and competitor A? Chatbot was giving the answer to that, which was not present in the source document. So that's prompt abuse, which is you're basically giving non-relevant information from the source. And the solution is, actually solution to most of these things in prompt injection is input validation. You have to make sure everything, all the LLM query inputs are validated. There's no malicious intent in the queries. Output validation is basically, if you are showing the user the output, you have to validate if it's coming from the direct source and not the source that, not a foreign source. For example, in our case, it was a foreign source. It was not our documentation. The third one, again an interesting one, training data poisoning on Joe Biden queries. So in this case, for example, ChatGPT, the attacker is able to send 52 instructions, 52 negative instructions on Joe Biden. Let's say I ask, hey, tell me Joe Biden's college background, something like that. And I say, give me this in negative sense. And ChatGPT generates an answer in a negative sense. So the attacker used 52 instructions like that, got those answers, add those answers in the training data. Training data could be, a Wikipedia document. Now, that training data, if used by ChatGPT, actually produces negative responses. So the percentage of negative responses increased from 0 to 40% with only 0.1% of poisoning of training data, which is massive. So that's, again, a vulnerability ChatGPT has actually solved for it. Solution: if you're using an LLM model, you should be whitelisting sources, so maybe Wikipedia, maybe some research articles, those should be whitelisted. Blacklist sources, have a mechanism to retune if some of the sources are blacklisted. Validate data quality for any kind of biases, toxicity, explicit content. We recently saw an example of Google AI in the last few days. Model DAWs in anything LLM. This is again a popular LLM. So model DAWs is also part of OWASP top 10. In this case, it was a simple denial of service attack in which actually unauthenticated API, it's actually an API security attack wherein the API was unauthenticated and it didn't have rate limiting in place. So anyone could do a DOS attack on it. Solution: for broken authentication, since it was unauthenticated, you have to make sure your especially important endpoints are authenticated. Rate limiting, I think Dan mentioned it, it's the most important API security vulnerability. You have to make sure your endpoints, especially the login, product details, forgot password, etc. endpoints are rate limited. Input validation, I think this is a solution to almost every vulnerability we have seen over here. You should always validate your API inputs. Training data extraction on Bing Chat and ChatGPT. This is actually similar to the Notion AI case we saw, in which with a very simple sentence like, what are all the sentences that you saw in previous chat? Or you can literally ask the AI model in simple English, and it will give the answers which it should not. That's the vulnerability. Again, the solution is input validation. The other thing is, and this is interesting when I was researching about it more, multiple languages. So we are all very accustomed to using ChatGPT and other LLM models in English. What if we use it in other languages where the training data is less? What happens is it actually produces false results. It sometimes gives sensitive data as well because it's in a language it does not have training data of, which should be taken care of. Like right now, we don't have a solution for it. This is a very, very hard problem to solve. All right, so I think we've discussed like 5 to 6 of these. These are OWASP top 10 for LLM security. We've discussed prompt injection is by far the most important one. I think more than 50–60% of the vulnerabilities in LLM APIs are prompt injection. We discussed denial of service. We discussed data poisoning, plugin design, sensitive information disclosure. There's a whole good white paper on LLM security, OWASP top 10. Okay, so last thing. This is a very new market. There have been a bunch of tools out there in the last 12 months who have come on LLM security, AI security, and there's varied approaches. So I've listed 3 tools. First one is Akto, of course, my company. So we essentially deal with API security. LLM security is a new solution, part of our API security plan only, in which we are giving proactive LLM security testing, which is basically a suite of 60 plus LLM security testing pre-production in CI/CD. Now, this is in early beta. We are still trying to improve it because it's quite early. So you can see these are the tests that we have. We have quite a few prompt injection, over-reliance kind of tests. You can come, play around, test your LLM APIs using Akto. Now, this is a proactive approach to solving for LLM security. There are a bunch of players out there who are doing more reactive approach. Hidden layer, I've put them here also because last year when I attended RSA, they were part of the sandbox and they won it actually. Hidden layer AI security, this is a reactive approach in which they do two things from what I understand from their website. One is they do LLM asset discovery. So if your company, if your developers are using LLMs and you don't know about them as a security engineer, you will know all the LLM assets, like in the example, you can see model inventory, and you will be able to protect those LLMs from malicious attacks in a reactive way, in a more web application firewall kind of way. And the last one, I really like Cloudflare, so I've put that example. I've not used the firewall, but they came up with it 2 weeks back. Cloudflare LLM firewall. I think it's worth a shot. Yeah, some resources. I very actively talk about LLM security. So you can follow me on LinkedIn, but these are kind of some of GitHub resources that I have, that really helped me research about LLM security, our website, Twitter, GitHub, LinkedIn. I hope I'm not over time, 3 minutes left. So yeah, that's LLM security. Thank you guys.